Hello, hello everyone. Can you hear me?
Loud and clear.
It's good to have you guys aboard. All right, so let's start our presentation. Hold on a second while I set my screen properly. Should start the game engines because they take some time to warm up. Okay, I think we're set. Okay, so first, really quick intro about myself. Um, I usually like to jump straight into the content. The format today will be 1 hour and a half presentation, a little bit more than that. And then I will open up to questions, right? Um, I'm currently a mentor for the game developer program and also tech art program for Vertex School. We're based on Los Angeles, but we're scattered worldwide. We're an authorized training center for Epic and Unreal Engine. And yeah, just like a brief intro. What have I done in the past? I've been a modeler and 3D animator since 1996, believe it or not. Barely internet back then. Um, I've been a EA Electronic Arts Los Angeles contractor from 2006 up to 2010. I worked in Lord of the Rings, Battle for Middle-earth, um, most prominently two, but also the first title, Command and Conquer 3 and 4. And yeah, those are screenshots from some of those titles. Still actively played to these days from the Electronic Arts RTS division. I've also been a producer of a really large, massive multiplayer online game called Taikadom, space-based, from 2009. I've developed some top-selling unit asset store packages for the Unity game development platform. One of them is Rage Tools. It's a 2D vector drawing and animation package. I've been a producer and senior developer for more than 20 games for Apple Developer Academy, which is an Apple US sponsored development course for both graduates and graduates. I've been a PUCPR, a top university in Brazil, a professor for digital games graduation course, and also digital arts course for 10 years. And more recently, I was the founder and city manager of First Foundry, a multinational studio from the United States, the Brazilian branch we had here for 8 years. I worked on pre-production of for many titles for Beyond Games and Laguna Games. I'm also the founder and creative lead of Flip Play Studios. Currently, I'm the lead developer and yeah, creative director for the Total Atomic Power real-time strategy game, which you may find on flipplay.co if you want to learn more about that. Briefly talking about the GDP program, the goals of the program is to learn C++ and create games. So that it is focused on Unreal Engine. Today we'll be talking about not just Unreal Engine, but a little bit about Godot and Unity. So in that course, we taught Unreal Engine interface, blueprints, and the API for Unreal using C++. and we go and develop increasingly complex games in the engine. It literally takes 9 months end to end, split in three parts, right? And yeah, at the end you have one artifact that you're scheduled to deliver, which is your capstone project, right? So basically build the skills up to that point. And yeah, we could talk a lot about Unreal Engine, but let's move straight into the topic now. And feel free to make questions. I will probably answer them at the end of the presentation for, time's sake. But yeah, let's talk a little bit about how modern games are really built. And I'll be not just talking about slides, I'll be using the game engines themselves and sharing a little bit of, the work process that I use. Not just on Unreal, not just on Unity, but also for some specific engines like Spring RTS, more recently rebranded or branched into Recoil. It's the more modern version of the engine, which is tailored for RTS games, which, as you guys probably realize by now, it's an old passion, something that I really like working on. So, what's after all game development about? Basically, game development revolves around those four topics. The first being the tools that you use. It could be an engine, and the game engine is, we're going to talk a little bit more about that, but it's the layer where you build your game upon. It's the software layer, it's the tooling layer, and DCC, or digital creation, digital content creation tools like 3D modeling apps, animation packages. If depends on the content that you're creating, right? Then you have to add the assets, which will probably be created on those DCC tools or within the engine itself, depending on the tool set you have available and the facts that you need in multiple aspects. Finally, you go to the logic where you set up the behaviors, right? Code and scripts. We're going to talk briefly about the difference. It seems like it's the same, but it's not. And finally, you get to the polish stage, which is actually not just a stage. It's a continuous process. As soon as you have something playable, you start play testing it because there's no second class or citizen to evaluate the quality of the gameplay other than a bad old-fashioned human brain. There's no AI able to tell if the gameplay is fun. It can take an average of what people think it's fun from other games, but it will not apply to your own game, right? So yeah, you have to literally sit down and um, play it a lot, hopefully with friends or family or with an entire team, depending on the size of the company and the resources available, of course. And that involves also balancing. We're going to be talking about balancing too. So yeah, keep those four stages in mind, but understand that they are intertwined, right? A long time and during the development process of the games. So game engines, like I mentioned, they're basically software um, apps which are used to build games, right? So you can think of them like operating systems for your game. So when you're running an app in your cell phone, you're not running on raw metal, right? There's a layer there between your app and your mobile device. That could be an Android-based operating system or an Apple-based, iOS-based operating system, but you have a layer, right? And it's always been like that because that gives you a higher level abstraction layer. So you don't have to be worrying about details. You have this layer which takes care of the nitty-gritty details of actually placing a sprite, which is an image which moves on screen, or handling the loading of vertices and their arrays and all the technical details of how to bridge and bring that into the GPU, which is your graphics card, basically. Right. So there are many, many technical details which are repetitive and it's heavy workload, and streamlining them into a tool which makes it easy for you to create games. That's the job of a game engine. So a game engine is responsible for multiple aspects of the actual game execution, including graphics rendering, physics simulation, if the game uses some physics simulation. Most commonly, even if there's no simulation, there's physics detection, right? Because it's executed on a very low level, most commonly on the GPU. There are also CPU-based physics engines, but most commonly that's deferred or sent to your graphics card because the graphics card is so much faster than your regular CPU processing, right? And then it simulates physics. It gives back the result of that simulation. And finally, you get the execution of logic, which may happen right before or right after the physics simulation step, depending on how the engine is defined. Um, Most commonly, physics happens after the previous frame drawing. And with that, you can understand that this is just a glimpse of it, right? The game engine does much more. It handles data, it handles player input. It handles all the output from the game, which might not be just sound and delivering graphics. It can involve even, haptic or physical feedback. And in your controls, if it's a VR device, it's basically syncing the gyroscope and all the tooling that you get in the device to what needs for your interaction with the system, right? So it handles a lot of things. And trying to build that from the ground up, some people find it fun, and some devs are, big defenders of not using game engines and delivering your own layer or using a very thin graphical layer just to, alleviate part of that. But most commonly, it depends on how much time you want to spend on fighting with low-level details or actually getting your game done. And yeah, it doesn't go without mentioning that the three most famous ones, there are many, like many game engines, not just those three, but the three most famous ones are Unity, Unreal Engine, and Godot. Each of them have their own pros and cons. There's no right answer. Like people keep asking me, like, what's the best game engine? And that that question can only have one answer, which is another question. It's like, what are you trying to build? What game are you trying to do, right? Because they definitely have, their strong points. For instance, I personally find Godot the best of the three for 2D games. Of course, it's a personal opinion, depending on what you're trying to do. Like if you're trying to deform your sprites or images on screen, Unity might be a better option. And trying to do that in Unreal would be super challenging. Like you can do that, but you have to resort to 3D models, right? Because there's no built-in function for deforming meshes. At the same time, you can say, well, but I can build my own extension in Godot and I have access to the full source code, which means you can literally reprogram and extend the engine infinitely. You can extend Unity very well to a good aspect, but yeah, we can potentially, you know, um, say that those two for being open source, they are, a different kind of beast, which means hundreds or even thousands of developers around the globe. They constantly submit updates and fix bugs and submit. It's not like direct updating the source code, but they submit what's called a pull request, a PR, which means, okay, I fixed that. And someone in charge of the engine or a team of engineers, high-level engineers, they review this code submission and adopt it to the engine. So it's pretty hard for Unity to keep up in that specific aspect because, well, Unity is closed source, right? You can license its source code, but it's super expensive. They will not give it away to everyone, even with money. They do some selection, and yeah, it's pretty complicated. And yeah, even if you get a source code, it doesn't mean you're going to understand it. It doesn't mean you're going to be able to extend it that easily, right? And build your own versions and, well, many constraints there. So yeah, but at the same time, if you check, for instance, graphics for 2D effects, you get the three of them are pretty good, for bloom effects and even normal mapping and other effects that it can apply on 2D. And I'm just talking about 2D games, which means like, just images, no 3D spaces. Um, but like I said, there are some sensible differences. Unreal is the least developed one in terms of 2D feature support. Godot is very, very mature. He has lots of bells and whistles for its 2D layers, like I mentioned, the formation, built in, etc., etc. But if you're talking about 3D graphics, then things totally change perspective. That's exactly when Godot it's the at the bottom of the pack. And again, you got to think about licenses too, right? Godot is basically free. Well, it's not basically, it is free, period. It's open source and free. Unreal Engine, it's open source, but not entirely free. Depends on how much money you made. And most people say, well, they ask for a decent share only after you make a lot of money. Can't remember right now because they keep changing the plans, but it used to be like $50,000 with a single game. I think they changed that later. And if you publish a game in their own store, like Epic Store, they don't even take a share, which is actually awesome, really. But of course, the visibility, the penetration they get from the exposure they get from sending or publishing your game on a platform like Steam is much, much wider, right? And that's when you start having to be concerned about shares, okay? Making money from games not as easy as people think. It's actually pretty hard. And after all the cuts that it gets from taxes and such, it might not be um, a sustainable endeavor unless the company is really well structured. And yeah, so we have those three in terms of totally different 3D quality, or I wouldn't say quality, is more like maturity and the level of the tooling that you get. So Godot, it's pretty poor for 3D. It's got some interesting like global illumination using SDF techniques, some pretty interesting things going on, but I would qualify it at the lower tier for 3D graphics. Still, they're getting better. And like I said, the progression of features will most probably be the best of the three in terms of ramping up, simply because there's a very active open source community, which takes Unreal Engine with a grain of salt because it's not fully free, right? And there's a big core behind like App Games, while Godot is like, the Rebel engine, which just came to defy the big players. So this is the kind of mentality which brought Blender, which is one of the top 3D modeling and animation packages in the world, brought it from obscurity, from a pretty bad 3D program, to be fully honest. I used it in versions before 2.6. It was pretty poor. Like you couldn't compare that to Maya or Softimage when it still was a thing, and later Autodesk killed it. But the thing is, literally, you would have a hard time um, making, nowadays at least, making 3D graphics look great. If it's stylish, okay, but if you want it really polished with all the bells and whistles, I wouldn't recommend Godot. And then at the middle of the pack, you'd get Unity 3D. Definitely great graphics. They just released, I think today, or yesterday, a new game which was built on Unity, which looks awesome. Can't remember the name right now, but yeah, you can just go to axe.com and check for one of the most recent posts from Unity, and you're gonna find that video there. It's very good looking. But definitely at the top of the pack for 3D graphics quality, you get Unreal. Not just for graphics quality, but the tooling. That's a very important part of when you're picking a game engine. If you go the game engine route, which I would recommend for 99% of the people, except if you're a top computer scientist and you really want to tackle a game engine. I had already a couple students which did it and they did it brilliantly, but it's a pretty hard challenge to tackle. Anyways, you go for a game engine, you have to decide what's the type of game you want to build. You want to go super photorealistic or even great looking 3D, that would be Unreal Engine. You want something that's easy to use because the learning curve from Unreal Engine is pretty steep. No way around that. Easy to learn, easy to extend, but you don't care about source code or even the pace of new features being added, Unity would still be a great choice. Yeah, definitely. Good 3D graphics, great extensibility, etc., etc. You want something a little bit more on the road side, and but yeah, growing up really quickly, and you don't need the best 3D graphics, or you're going for 2D graphics. I would go to that's in a nutshell, right? Obviously, there are many caveats for each engine, and there's no, like I said, no silver bullet. You have to take your time, research and decide what you want to build, and then you pick the game engine for that specific game or task. Moving on, assets. Assets are the building blocks of a game. There's no better definition for that. So if you imagine a big Lego piece with like thousands of blocks, you still have a single piece, right? And of course, they're bigger pieces relatively than what you get in one of those massive models that you find on any shopping mall, but they kind of work in the same way. So you may have 2D sprites and textures if your game, well, textures you're most probably gonna get if you're playing 3D. And the difference that both are images, okay? But they serve different purposes. So basically, when we talk about sprites, it's one image that's chopped off, usually a region of the big image, which you build what we call an atlas for multiple sprites to make things more efficient. A big image loads much faster than hundreds or thousands of small image files, right? So it's a common optimization approach to just pack as many small images as you can into the same texture size, as long as it's not a massive texture size because there are other problems related to that. But if you balance it right, you usually do this sprite sheet for images of the sequence of frames that you're going to make. We're going to be talking a bit more about animation in a second. Or use those images to wrap or dress up your 3D models. And that's what a texture is about. A texture is basically an image used to wrap up or to be used as a channel, but also wrapping up the model with something we call a UV map. It's a map of coordinates which can map each vertex in vertex in 3D space to a pixel or pixel region, right? A block of pixels inside those images, which then become a texture, just technically speaking. But anyways, you import those as images, and then later in the engine, you define what's the image goal or type or usage in the engine. And then you get the 3D models, obviously, for 3D games. And they can be used for other things. Like I mentioned, you can use 3D models, like flat 3D models to make 2D animation as well and simulate vector graphics. That's a pretty common use case because vector graphics are better. The performance is better when you're basically converting them to polygons because every GPU, every video card that you're gonna use, it's optimized for triangles, polygons, right? We say polygons, but at the bottom end, it's actually converted to triangles always. So yeah, when you convert things into triangles, you get the best possible performance. And animations, which basically defines how do you deform these meshes to make them animate and jump and take multiple actions. We'll be talking about that too. And then sound effects and music, obviously, never forego the importance of sound effects and music and being able to wire them to specific events, even minor events like footsteps, and that will give all the ambience for the player. And just try to play a game without sound. Think about playing Mario without sound. Unless, of course, you have some hearing limitation. It's just a way weaker experience without audio. Okay, so yeah, you can't like it's a very common mistake in game development that developers focus so much on the visual aspect, the interaction, which is key, of course, and they totally forget about sound effects until a later stage. And then they come back and they try to, kind of make a hack And that rarely works because the music and sound effects, they have to be developed with the game in mind. And usually you need some evolution time and some maturity time for them to sit down and land on the game and work with the game, not as a second guess, right? So very important to get this produced and integrated properly. And other elements, like I mentioned, fonts, like text fonts, but there are many other minor elements that you might be using, like icons, which are also images, etc., etc. And they're usually created with what we call DCC, digital content creation tool. So that's when I'll take a brief pause, and I'm going to show you guys a little bit of this process and how does it happen inside the game. So yeah, here we have Unreal Engine, and let me show the specific asset that I created here. Just I think I have it pre-spawned. Yeah, that's not the actually entity or actor to be spawned, but you have an idea of what I mean. So here's the camera view, and here's the 3D mesh. So if you check the definition or the blueprint for the specific actor, right, which is this entity or playable entity or movable entity here, I just added it. And I'm going to be talking a bit more about this in a second, but if you check here on the viewport, you can see it's got one animation going, right? Which is just the idle animation. And yeah, this was created in a third-party application called Motion Builder. Could be done in Maya, yeah. And even nowadays, you can create animations for this character. Actually, here inside of your engine, you can just do an add level sequence with that selected actor and just start using the controls if you have set up a rig or just and rotating and creating keyframes along the timeline. Okay, so that's one of the contents that we cover during our GP course, and it's super powerful. It takes some time to set up, especially set up the rig inside the engine. There are advantages to creating the rig. The rig is basically the controlling system for the joints because this guy here, let me open the actual mesh so you guys can see that. Let me open the skeletal mesh asset. There are many elements or control elements which are used to deform this mesh. So it's very common to get the character on what we call a T-pose. And then you have, all those pieces in a hierarchy to define left leg, left upper leg, foot base. And then, you can animate it either using the snap or not, depending on what you're trying to achieve. So I'm disable snap quickly to show you guys. And basically by setting up keyframes or um, basically coordinates a long time, you can animate those parts and pose the character to reach a certain specific pose that you want or a sequence of poses. And you can see that there's both the smooth deformation like we got here and the hard deformation. So it really depends on the character. So you get some parts which are flexible, others are rigid, right? For the specific character, it made sense for the animation at hand. So then you go things like, oh, let me take the spine and let me, rotate it to maybe simulate some breathing, and then you just do a keyframe like this, and then like 1 second after or half a second, depending on the speed that you want, you make it rotate like that. And then a long time, you see the breathing movement going, right? And then you store that in another file or asset, which is actually stored in your project folder or content browser. Okay. While we talk, I think I have this project in Unity as well. I think it's an interesting way to show the correlation between different engines. I don't have this one in Godot, otherwise I would show you guys. I think it would be pretty interesting. Um, Yeah, that's the one. Let's see if I have this project version installed. I think I do. Okay, so while it opens, let me get back here. So yeah, how does this thing, how is that thing mapped, right? Because I've just shown the skeleton, but you see, it's like it's got details. It's pretty well painted and all that. How does that work? You see all the reflections and you see those very small details. Are all those polygons? Not really. If I go to wireframe, you see that there are actually very few polygons. And the triangles, like I said, are the bottom line here. So I know it should be kind of hard to see in transmission. See if I can get rid of the yeah, I can get rid of the grid or the we'll try, yeah, just gray ambient or gray wireframe and let me remove the grid. Okay, that should make it clear for you guys to see. And yeah, check how few polygons I have. It's just it's less than 1600 triangles, right? That's ridiculously low. Like even on a RTS game, you can target around 3.5K triangles or 5K triangles. And an RTS, I mentioned RTSs because just like Dota and Defense of the Ancient or League of Legends, when you get multiple entities on screen, the more different objects that you have moving on screen, the harder it is for the system to keep up with not just rendering and animating. That's actually pretty light, but controlling everything that the entity has to process, right? The actor or game object, depending on or even the node in Godot, it's called the node, but basically the playable entity, right? Um, it has many things to do and decide, and to do that in real time, it's pretty hard because there's lots going on. It's not just what the character is deciding, right? You have the game rules, you have all the um, all the high level decisions. Sometimes you have coordinations of AI agents or with machine learning or not. And to get all of that running at 60 frames per second, it might sound easy, but it is not. Okay, because 60 frames per second, well, it's if I just enable that, I think I have this here. Where's that? Report stats. Yeah, we enable that and see we get that going with um, not a lot. Yeah, we just get the visualizer night. Yeah, there's some details you can add to check for performance. I had a presentation on that. And but yeah, just looking for the actual let me get the show yeah thing going. Show debug. In a second, let me mute this. Forgot it. Yeah, usually just using the do not disturb is not even enough. Nowadays, I have to use airplane mode for some reason. I think iPhone is pretty aggressive with the call methods, really recently. Um, but anyways, yeah, let me show you guys. This is the flat view. Okay, so this basically has no shading and it's not even taking the lights. So it's pretty PS1, PlayStation 1, PlayStation 2, because PlayStation 1 had no actually bilinear filtering. This is more like PlayStation 2. Um, yeah, a little bit worse because there are no shadows, internal shadows or anything. So this is the lit view. You go um, to lit wireframe, and then you see the wires on top of the triangles, right on top of the mesh. But that's definitely nowhere close to what you get with the final with the final detail lighting. So you have tail lighting shows you all the details like the normal maps, which is are basically textures which drive this relief, okay? that you're seeing here, all those small bumps. And all of those are defined, yeah, like for these ones here at the mouth. Okay, where you can see that. Let me try to find the right zoom level here. Right, so you see those small dots, carves. This is just texture. Um, you can see from the wireframe that this is just two triangles. But this is how you make things really efficient by generating those textures and those DCC apps and bringing them into Unreal. So let me find the actual textures. Yeah, here they are. So, for instance, this is the diffuse texture, right? And this, looking at it, doesn't feel like it's the same color information that you're seeing on the models, but just by having a really smartly laid out UV map, you get this kind of the kind of final result that you're seeing here. Okay. And but yeah, we have multiple other passes like what's gonna be bright, what's gonna be able to light up the scene, and that's what we call an emissive, right? And you see that it's actually, if you look at this block, it is actually the same piece that is actually at the top part of the shoulder, right? And I know that because, yeah, I worked on this model, so I know exactly where each place falls, but creating this UV map is pretty time intensive. It's getting better. Recently, we got better AI assisted tools for doing that, but it still requires some major hand tweaking. So to get perfect quality, of course. And then you get other maps like the metallic, which tells you which parts are more reflective or less reflective. Black is less reflective, white is more reflective. The normal map, which is one of the most important ones, is the one which actually gives you all the detailing that we were talking about. And things like, the bumps on the handles that you saw, they're pretty hard to see even here, but they're defined in this map as well. Okay, so some details are really, really tiny, and you can kind of distinguish them when you zoom really into it, but the final rendering gives you that result. So basically, this is a very wise trick where you get on the blue channel the height information, on the green channel you get the top to bottom light information. So that's why when you select, this channel, you can see the top part being uh, clear and or light, and the bottom part being dark, because that's how the light has to reflect off of the surface on this angle. And then if you go and check the red pass, you see that the light parts are to the right and the dark parts to the left. Okay, and that's how it creates this illusion, which is like a hologram projected on top of the surface. And then when you have all those material passes added up together, you end up with a final look of the model. And of course, part of that is using the some specific technologies in Unreal, like the lumen system for high quality lighting and reflections and whatnot. And then you get the shadowing. You may use Nanite as well, which will give you much wider detail, and then you can get rid of the harsh silhouettes. I could get like real relief here if that was the goal, right? Very easily and with good performance. Nanite is a very famous technology in Unreal, which is not it's not, ideal for mobile devices, honestly. But for any mid to high-end PC, it just looks brilliant and gives you so much more detail. And you can even apply that to animated models as well, in more recent versions of Unreal Engine. That's not something you can get specifically that on Unity, right? So yeah, this one is Unity. Let me organize my layout a little bit. So you see in Unity, that's the same model, and you get a very good visual result as well. Like I said, if you work well enough. The thing is to get to this quality level in Unreal, it's basically a single click. Honestly. It's ridiculously easy. And to get to this level of quality here in Unity, it took me hours, honestly. And of course, I worked with the engine for, you know, it's going to decades now, honestly. I started working on it in late 2008. It was still OS X only. And there's some, some things you have to work hard on or use plugins. So for instance, the shadows, they'll never look as, well, never is a harsh word, but it's hard to make them look as great as you can get them in a real. The overall performance is better in Unreal, so it's always there's always a trade-off. And if you push the graphics for, increase the resolution of the shadows and you use Cascade, Shadow Map plugins, whatever, you get better shadows, and then you pay the price in frames per second. So there's always the trade-off. But yeah, just to show you guys how this works here, it's basically the same assets, right? It just changed a little bit the way that it's shown here, the way that you set up the import settings. In Unity is dynamic. In Unreal, you make an import pass which generates a specific asset called uasset dot uasset. But notice that it's basically the same, not basically the same image really. Okay. And you set up what we call a shader, which is the configuration used on the mesh to get this render. So in this case, I use the same of Autodesk because that's where I originated the program from, the model from, sorry. And then I just fed into the right images just by drag and dropping into the right channels. In a Unreal Engine, you do that using a material editor. Usually the material will come with your FBX file. Let me get that. Just find the material. I think I stored it somewhere around here. Let me see. Or I can just get it from let me close those down and get it from, what is that? Oh, that's the skin mesh. There's the skeleton. Find the right material. You can also search from material types like texture or material, and that's going to filter all the materials that I have in the project. And you see there's this node graph where it's basically the same, just using a nodal process. You can just drag any texture that you want straight into the graph and wire them into the right channels. So it's very similar to Unreal, to Unity, but using a slightly different system. It's a node-based system, which actually there's a similar one in Unity called shader graph. So usually you change the names, you change the UI, you change a little bit, how to use it and how many nodes you have available here. Unreal has a ton of nodes. Shader graphs also very powerful, and on the Unity side. And sometimes the nodes are catering for specific features in the engine, right? But there are some things in Unreal, for instance, this ability to just update the global lighting dynamically. You can see here the result of the shadow, soft shadowing going here at the back and on top of the surfaces. And, this is just amazing. And the performance is just awesome. This is pretty hard. You can achieve similar effects in Unity, but like I said, a way more complicated setup with probes. They're trying to make it easier, and the final quality, honestly, in my opinion, is not on par. It's close, but it's still a second place. Okay, so yeah, I hope that gives a little bit of an idea of how those assets are set up. I have a little video that I stored here. Probably enlighten some more things. Let's see. Yeah, this is an example from 3D Mesh Generation Program and some animation. Yeah, we're going to be talking about animation in a second. Here you can see the process that we use to generate those UV maps. It's called UV layouting. There are multiple programs and processes to do that. You can use regular tile, regular islands, or you can use tile sheets, which I've been using a lot recently, which saves up lots of texture space and it's very reusable. I can show that if you guys are curious about it. But basically, you can have unreadable textures like that, which are pretty hard to use, or you can have, properly um, built textures with decent UV maps. So auto-generated UV maps are not good. So in the process of painting textures, sometimes it's manual, right? But using digital tools, you can start from scratch, having your own concept. You can use tools like Substance Painter or Mudbox to create this detailing, these marks, or you can even use Blender, which, like I said, is a free process. There are many plugins like Unreal. I personally, let me show you guys. I personally use a lot of plugin called ZenUV. Pretty much every native UV layouting system is pretty poor, so I tend to not use it. This is a model that I was playing. Actually, I'm updating it to my game, and you can see that it's a low polygon model, but it's got plenty of interesting details going, just like what you saw in the robot. And let me show you guys the actual UV. This is what we call a tile sheet. A tile sheet, it's again an image, right? So no big news there. An image, but it's got a specific layout that allows you to quickly, pick parts of the textures and apply them on specific areas of your model. This technique is recent, it's kind of new, and I've been exploring it a lot because with the single texture layout, which looks a bit overstructured, so you have to kind of design how you're going to use those macro parts of the layout, right? So in this single 4K image, I have four base materials. One that we call the faction color, which changes a little bit depending on the faction, could be more purplish or more yellowish. Then you got the base or light, as we call it, metal color, the dark metal color, and the team color. So this one changes. You see here with a shader simulation using blue, but that could be red, yellow, whatever your team color. So when you're playing multiplayer, you pick or select your team color, right? And yeah, this is basically it's what's going to be replaced. So we use base as white and multiply by the final color in the shader. And then you have those variations where you get like, faction detailing one, faction detailing two, and faction color with light. So all of those orange elements, they are lit up elements, which actually become bright inside the game. And you have the same logic for the light metal, the dark metal. The only difference here is on the team because we don't really need that much detailing for team colors. So I just have one detailing for team color down here, and I've reserved those three subtiles, if you want to call them like that, for things like builders or constructors and tread marks or tires and specific textures for vehicles like tank treads and yeah, um, and other detailing parts for vehicles. Okay, so that requires some planning, but once you have this working, you can easily apply those textures, right? So part of that is slicing the object properly. So for instance, if I wanted to have this part here on a separate um, tiled, I don't know, maybe I wanted to apply one of those textures here, I would go and first I would slice it. So I do a mark, right? So basically now you see there's a red line from the selected edge. I'm on edge selection mode. And then I can just pick this part and do an unwrap process. And I restrict that to the selection only, so it doesn't redo everything. And I can now you can now see that I got the same island here, but I need it fully straight to fit the layouting. So I go to the quadrify option, and I turn that into a quad, and now it's straight. And notice that it doesn't deform the mesh; it just deforms the UV or the mapping, right? And then you can go to the tile sheet option, and there's where I've set all my presets for things like the faction 2, faction 3, dark 2, you know. So I've laid out these sections. So when I load, for instance, like I said, I wanted I think it was a light. Let's try a light detailing. I probably use this one, for instance. So let me go and load light 2. Okay, so now I got the frames and can see the frames using this. Here are the sections that I can use. Then I say, okay, I want to map this part of the texture right in here. So I can just select the trim and do a fit to trim. Okay, and it's not rotated properly, so just because it can't know, those are different spaces, right? It doesn't know what's up or down from the image. Here it knows, but not here. So yeah, so I have to literally do a rotate and then fit again, and now you can see the texture. Of course, it's too distorted because the difference in the geometric shape and the mapped taxo island, which is the specific terminology for that, it's way too different. But other parts would work better. Maybe I can do this guy and do a fit trim, or wait, no, I had to rotate it again. Let me see. Oh, I got the wrong island here. Let me fix that real quick. Yeah, so just select the trim. Let me try fit to trim now and see that it works much better, right? So that's how you can easily apply skinning parts to any part of your mesh and basically reuse it for a multitude of meshes. So just as an example, to wrap this bar, let me open this big file here. I don't want to save it. It's gonna load it. I think I clicked it right. Yeah. Okay, so this is the one, but notice that I have many other models, right? The scout drone, the laser drone, the missile, yeah, this this World War One style fighter, and they all have a different texturing, but using the same image, which saves up lots of texture memory, and it's just so much more efficient than having one specific image as a texture for each separate unit, which is the traditional approach, right? So this is just one of the ways you can optimize your layout of textures. Okay, so um, back to our slides, and yeah, I know I said I'd only reply at the end, but let me check some of you guys' comments really quickly. So Unity and Unreal Godot game engines have improved significantly in dimension and a lot easier to use than 10, 15 years ago. Oh, you bet. I come from the time when I think the first game engine that was kind of accessible was Torque, and it ran in like 10% of the PCs we had back in the day. It was, oh my God, so incompatible with everything. And yeah, and then a Unreal Engine started costing about $1.5 million for each game, the license. Yeah, somewhere around that, pretty ridiculous cost. So why is the auto layouted UV map generally worse? There's some reasons actually, Jen. One of those is that the buffering in the edges. It's kind of hard to explain, but imagine that you have some blurring when you get close to the edge of the island, okay? And that um, actually changes depending on the distance of the mesh in game. So those are kind of dead giveaways of where you place your stitch, right? Where you cut off, you saw me cutting off part of the mesh to define that region, the islands as we call those. And yeah, so if you don't create a texture properly, which means adding buffer. So if you have the square, you need to have, you know, it's spilling off to the edges. It's kind of like an inflation, right, of the texture. So obviously, any pro generation package where you paint upon it, or if you're using Substance Painter or well, pretty much everything these days. It does give that to you for free, but that takes up space, right? So if you have too many tiny islands and you still have to add the buffers, you end up losing resolution for what matters, right? Which is the actual content of the island. So having all those tiny blocks just wastes texture or texel, which is the right term for textures which are being applied to 3D mesh. But anyway, it's going to be resolution or degrading the resolution at the end because you're basically shrinking the amount of pixels for each island just to be able to blur the edges or to extend the edges so you don't get the artifacts, right? So it's never a good idea to split up too much your texture, your UV islands. Okay. Um, I have to listen to it. Oh yeah, no problem, Charles. It is everyone that's that got its slot here will get a link to the recorded video. Okay, so no worries. Yeah, that's true. Okay, yeah, watch the replay. We'll be there. That's it. Okay, so let's keep going. Um, a lot to talk about too. So now let's talk a little bit about animation clips. And those are basically the data, like I said, that you record inside the engine to drive the movement, okay? Or anything that the character can do, right? Not just the movement. Could be the attack or the multiple attack actions and death animation. So each piece of animation, we call it a clip. In Unreal Engine, it's called a sequence, but it's pretty much the same thing. And there's even another concept or wrapper, which is called a montage. So Unreal Engine has all those specific terms for the ways that it adds metadata and handles its data. And there are other techniques. There are multiple techniques that you can use to be able to apply those animation clips onto the actual mesh if it's deformable. And I've shown quickly within Unreal Engine the layout of the bones and how things are parented, how they do deform. And yeah, that can be done using interpolation if it's for 3D model, and that's typical animation, or if it's 2D and you're not using um, keyframe based deformation techniques, which is also available for 2D, especially in Unity. It's pretty powerful. Um, you will do it frame by frame, or you just have the sequence of frames to build the illusion of movement, right? Which is the classic 2D animation way of animation, of creating animation, the illusion of life. So yeah, going back here to the actual engines, you can see, let me just remove the filter, otherwise it will not let us see. Okay, so here we have some montages like the jump montage, right? So when you click space, you jump. And you see here the timeline of the duration time for the animation, and it's looping, right? Because of its specific setting, it's set to be looping. But when you actually use it in game, it's just one shot, okay? Then you have, just bring in the palette. Yeah, so here are all the animations, and here are the montages. Montage, they basically override everything that could be happening in the interpolation part. So for the movement, we get all those clips, and they're not even that many, but that's enough for a smooth animation. So you have things like running back left, running back right, backwards, forward, forward left. So we have basically all directions, and those are arranged into the actual, let me get the blueprints, ABP, SaltBot. I have a couple done really. So yeah, this is the animation blueprints. The blueprints is it's a way for you to create automations and systems interaction in a visual fashion using what we call nodes, which are those blocks. Inside Unreal, we use blueprints a lot. You can build, I wouldn't say everything, but almost everything with pure code. But there are some things which just doesn't make sense for you to spend time, on code when you can get it running as fast as, and it's not everything, by the way, obviously. C++ is faster than doing things in blueprints, but some things are just fast enough on blueprints that is not smart to building or rebuilding that on C++, and the actual animation blueprint is one instance of that. So here you see that you get the input from the controller, like as the player holding it to the right, to the left, forward, backwards, and that's fed into a blend space. And what's the blend space? It's basically defining the animations which fall into each position. So imagine that's your thumbstick on your game controller. That's the idle position. So it's not doing anything, okay? But like it's saying, hold control to set the preview point. So just hold and move it up, and that's slowly transitioning that to move forward because that's the animation set in this point. And now it's going to run forward. Now it's move backwards or walk backwards, and then run backwards, right? And then you have, so here are the previously created animations: strafe right, strafe run right, and then, among those extremes, you get the interpolation so that it goes smoothly from one state to the other. Okay, like, so when you're just strafing slowly with your controller, that one will be interpolating really with small steps. Okay, and the same for, yeah, that's a diagonal forward, run diagonal forward, right, and you have the intermediary steps going on, right? So this is what you get from a blend space. And it works exactly the same in Unity. It's not that different, really. So let me get the SaltBot, and you have the avatar and the controller. Let me open up the controller. And you have all the state management that you basically get in blend spaces here. And you go to the movement blend tree, and you get all the animation clips for the movement going on here, right? Idle aiming, walk forward, backwards, same clips that you saw going there, right? Strafe left, strafe right, run forward, etc., etc. And that's tied into a blend tree. And look how similar it is to Unreal Engine, right? So of course you don't see those lines, etc., but yeah, it's pretty close. And you can basically, check the result here, and you can just drag the red dot and see the result in real time, just like you can do holding control in Unreal Engine and check the interpolations, etc., etc., right? So it's pretty much the same, okay? Um, yeah, of course it changes some stuff, like, yeah, the parameters, how you can tweak them, what's the speed, you can adjust the speed for each, and the Unreal Engine could do the same, but you have to open the animation clip, and you added the speed in the wrapper for the animation clip. But, like I said, you get the same stuff in different places, right? So that at the end, you get the playable results like we have here. So yeah, that's the editor view, and here's the actual game view. So if I hold shift, you can see the result, orbiting around, holding right mouse button, holding shift, jumping, strafing, run strafing, holding shift, etc., etc. Okay. So yeah, that's basically to show you guys how it doesn't change that much from one engine to the other, just the buttons that you have to push. But once you learn how to do things, it's the philosophy is the same. So let's see. Yeah, the same generation we already discussed about. Um, some of the production panes. That's actually a tool which was just released to improve UV slicing and generation. That's pretty interesting too, actually. And after that, you get, I think it shows here, not sure. Yeah, no, just that part. Anyways, okay, so back to our slides. And you also have the frame by frame techniques. Okay, so yeah, I won't be showing that, but there are many deformations because of the time constraint that we have. Still have some slides to cover, so let's keep moving. Water. Oh, it's over here. All right. So Coding, game logic. You have basically it's basically how you define the game space. The game space, it's a bit like UV space. Don't think about it as a top, down, left, bottom, Z, X, Y. No, it's not like a 3D space. It's theoretical space where you basically define this loop, we call it game loop, which happens from the input to the output, and it goes through the game rules. Okay, so yeah, if you think about the game rules, yeah, every game needs to have game rule. Otherwise, even if it's a puzzle, right? The puzzle has a rule, which is you win it when you defeat the puzzle or when you assemble all the pieces in the right conformation and space. But you need some rules. No rules, no games. Even life has its rules, right? And it's not even an actual formal game. But yeah, you have to process the input in some specific ways. Not always you want to register one action because you just clicked the button. Many times you want the action to be triggered only after you held the button for 2 seconds. Or if you're playing Street Fighter, and you want to create a Hadouken. By the way, the movie is coming. We got a new trailer. Looks good. I liked it. I especially like Blanca because I'm Brazilian, of course. But yeah, anyways, back to the point. From input, if you go with the Hadouken, you do something like, bottom, down, down, right, and then right in a specific time frame. It's about 0.25 seconds for each. Um, and then you click the one of the hand attacks or punch buttons, and that'll give you one of the three Hadouken strength types, etc. And how's that defined? It's not just a button click, right? You have to define this behavior in the logic of your game, and that's actually UI programming. And some people think that UI programming is just the visual interface because it's called user interface, but that's not true. Visual interface is part of it. You have to think about all the input and how does it tie with the gameplay, okay? And that's closely um, tightly coupled with the game rules. Because the game rules, for you to interact with the game rules, you depend on how is the input um, defined. So there's the design aspect where you create those criteria, those all of those concepts. And sorry if I don't have one slide talking just about design, but I hope it's kind of obvious that you cannot build a building without a blueprint, right? Without the proper architectural path. But yeah, those game rules, which is the number one artifact generated by design, they process input, but they also have to prepare the data that's going to be output because it's a dynamic interactable board, right? Imagine it like a tabletop game. And the tabletop game, you know the rules because you read that in a booklet of sorts and you implement the rules as you're playing it. But many times you're like, you implement the rule wrong. Oh, I thought it played like that because I played 6 months ago and I don't know why the game now cannot end. The game got to deadlock. Then I go check the book like, oh my God, I did the wrong thing, right? I forgot the rule, I implemented the rules wrong. That's why the game is broken. Well, that doesn't happen exactly like that, at least with digital game. In a digital game, you get all the rules literally baked into the artifact, the interactive artifact. And that's what the game logic is about. How does it process the input? How does it process the logic, right, of the actual game rules? And how does it prepare the data to be presented to the player, which is the output pass? Because you can think that, oh, I need to show a particle effect like a dust or explosion or muzzle effect when you fire a weapon. And that's just the final output, but what defines that this should be played in that specific moment in time? That's where the game programming goes into, right? And you also have to wire up the assets and behaviors because the assets are just pieces on your disk. They do not spawn, they're not created in the game by themselves. So what's the pacing for the NPCs being created on the game, on the level, on the map. And all of that depends on how the logic is set up to make that work. And behaviors means, things like how do you earn an ability? How do you ramp up in level if it's an RPG or a MOBA of sorts? All of that is defined in logic. And it's not just about programming in text. We also work, and we work a lot with scripts. And scripts can be visual. Scripts can be a really high level language like Lua, and that's still text based, but it's called scripting, just kind of differentiated from a more lower level approaches to coding like C++ or even C sharp, depending on the engine, or Python. It varies a lot. And that's just the language. It's the syntax driver for how you define the logic. But you also can do things visually, and that's where you get things like Unity Visual Scripting, which is now built into the engine. It's been like that for a few years now. And Blueprints, which is started as Kismet, and is now called just the Blueprint layer on Unreal. Okay, so just to give you guys a quick glimpse of both, you have here, for instance, blueprint for the salt bot, like everything that drives how it's gonna, react to actions from the player. It's here. It's defined in the event graph, and I try to make it as organized as possible. But of course, sometimes you get a little bit of wires crossing here and there. But as a designer myself, I try to keep things relatively clear. And some of those are pretty simple. Like for instance, jump input, right? What does happen when this event of the action called IA jump is triggered? Basically, when it starts, and you can check the flow here, it applies a jump. And once the action is completed, it does a stop jump because it's a continuously triggerable action. And if I just go for IA jump here, search for it, you will see that it's a pretty simple action. It just takes one digital input, which means it's either on or off. And as it has two events, the press and release. So you can add as many events connected to that value type as you want. Okay, as you need, actually, not as you want. But you can keep just adding them, and you have the possibility to change. So it's like hold and release, pause after that many times and intervals, etc. So each of them, you can just check you know, their um, their description from just hovering the option, or even coordinate actions, which is um, super sophisticated ways for you to set up sequences of actions that you have to, like, I don't know, maybe hold down, you know, hold down and then click A, and then for 1 second, then push forward and press B, right? That's the typical chord action. So, and there are also combos, which just fire sequences of triggerings, each of them with different index, and so on and so forth. This part is really, really fleshed out in Unreal Engine, much better than its competitors, really. Um, but anyways, you have to wire that up to so that it does something. Okay, and that's the something that does. And jump is a predefined node. You can program your own jump logic, but Unreal Engine just gives you that for free. And overall, Unreal Engine is always like that. You have, a kind of steep learning curve early on, uh, but and then for you to start making your game, it's lower than in other games, other game engines. But at the finish or polishing stage, Unreal Engine is way more powerful. It'll give you way more bang for your buck, and that's the gist of it, really. Here you can see other things like what does happen when you shoot. It just checks if you can shoot, like if it's not reloading. That's what a branch does. It checks for a condition. You have a variable here which is checked against. And then if it can shoot, it blocks the shooting. So the next time you shoot, it will not shoot because now can shoot is set to false. That's what this ticking thing here does. If it's uh, not ticked, it's false. If it's ticked, it's true. And then after that, you just follow the flow between the nodes using the white lines. which are connected through the execution pins. And then what it does is plays an animation on the mesh, which is the character mesh. You can just drag it in here and get a reference from it, right? And then you connect it easily to the skeletal mesh component that's going to be playing that animation. Then you select the montage to play. It filters from your component drawer, your asset database, and you can set things like the play rate and should it interrupt any other montage being played, etc., etc. And you can even fire other events or do things after it completes, which is pretty common. Like right when you complete, you set can shoot to true so that you can now fire again in another frame. So this is typical and very simple to set up logic. There are other more complicated ones like the movement action, which takes input, etc., multiplied by speed, the camera input with right mouse button, and any montage like the crouch and etc. Okay, but that's the whole logic for the character is set up here. So it's not super complex. It's as long as you check each block individually, it's not that bad, you know. And it doesn't use tags for designers who really hate working with tags-based approach. This is really easy to work on. You can split on multiple graphs to even to organize this even further, so that here you only get the native system events, then on the input events would go to separate the event graph and so on and so forth, right? You have a similar option here in Unity, although it is more common to do things using C# scripts like this one. Let's see if this is wired to writer. I can't remember. I think it is. It'll be easier to check the code. Um, yeah, I'm opening that on Writer, which is a third-party IDE, free for most users. And you can now see a similar thing to what was set up in Blueprints, but using Unity API, which stands for the programming layer or programmable interface, where basically you have the commands which you can use, like, you know, setting up the structures like the animator. And I basically build, that's just, you know, getting a easy to reuse reference so that I can use it later. The core of the logic is here. So you can say, well, this is much smaller than you get from a blueprint. The blueprint tends to get, you know, bigger. This is more concise because, for instance, setting up a variable where you take the horizontal speed and you multiply it by some factor just takes one line, you know, and in blueprints that would take like 3 nodes, you know. Or if you create a macro, it can even be a single node, but then you have to create that macro, which will take 3 nodes. Yeah, so this gets more concise. So for really big chunks of logic, or to, you know, intricate trees of decisions where you do, oh, if this and that, do this, otherwise do that, but if this, do that other thing. You know, if things start getting too complicated in terms of logic, usually it's clear to use regular code. And yeah, it changed the language changes here, C sharp. For your engine, you use C++ if you're going for code, which is a more complex, but also more powerful language. But, you know, some people will prefer doing things in terms of logic on code because it's, like I said, it's when you get the hang of it, it's faster. Nowadays, you got solutions involving LLMs, which I recommend if you know, can read what's being generated and you can tweak things so that you don't become a slave of the machine or the big company that's running the system. It gets your speed, you know, really much faster. But it's always important, first and foremost, to know the engine and know what should plug into which place, because no artificial intelligence will know what's in your mind. And knowing how to actually evaluate the game and being able to, you know, accurately tweak parameters to achieve the target goal is something that, as a game developer, you always have to do. Okay? So yeah, that's a quick glimpse on coding. And then we get to the effects and feedback for the player. And that involves shaders, which is basically a shader is a program which defines how is the light reflected and how does it bounces off the surface and how does it actually hits the camera, which gets the pixels rendered on screen, right? So that depends on the lighting that's being set up. If you're going for a cartoon-like rendering, you use one style of shaders. If you're going for super photorealistic style, you use a different set of shader, different strategies. Shaders are usually defined visually nowadays because they're compiled automatically and they're very efficiently compiled. It's very hard for you to create a program in text in HLSL and get, there's, well, actually, there's no way you can get better performance than using the automatic compilation from nodes. The only difference that some people are used to program in text, but if you usually those guys are who build shaders are tech artists, which means they are artists, but they also can tackle tech or programming. I'm a tech artist myself, and yeah, building shaders is pretty fun. You can get some sophisticated effects easily. And I will load another project here. So let me shut down this one. I want to apply anything. I'll open another project from Epic. Hold on a second. Games Launcher, where I will be able to show a little bit more about shaders and particles. Oh, actually, I should go to the Real Engine, not the store. Get back here. We get the project that we finished or close to that. Okay, while it opens, I'll just keep talking a little bit more. Yeah, I don't think I need to rebuild it. Let's see. If it breaks, I just build it from Writer because this project was converted to C++. So the right way to open it in Unreal is to open the project in Writer and then you start the engine from there. But let's see if it works from the previous compilation. Anyways, shaders what, like I said, define the final result of the light hitting the surfaces or polygons. Then you get particles, which can be used for explosions, smoke, magic effects, spells, etc. And you get events. Like events are also used for feedback. Sometimes you get screen shaking. You're gonna get, things like when you get um, glare from after a smoke bomb or something, right? Yeah, I don't think this is gonna work. So let me open that from Writer. So let me just open the project. Um, yeah, open it in here. Let me close Blender, not be using it now. And okay, that's the actual project for the Vampire Ripper game that we've worked on GDP 12 cohort, and you can get a glimpse of C++ here, some part of the attribute set that we use to for its game playability system, and yeah, some of the code, more player focus. To see, it's obviously just from a glimpse, it's more verbose than what you get in C Sharp, which is just the nature of how things are built in C++. It uses a bit more symbols, and it's a tad more encryptic overall. But at the end of the day, it's not that different in the sense that you have some system events, you have, typical loop structures and things like delegates and whatnot. So it does change a bit, of course. It changed significantly, but yeah, you always have a little bit of a connection, but the workflow is the same. Like the event that happens when you run something, the first time when every frame updates, when the physics update, those are pretty consistent across multiple game engines. So yeah, while it builds, let me keep moving. So yeah, those are done with particles, and there are multiple types of particles, not just, I forgot to mention, there are also fluid-based particles, which are very sophisticated in a real engine. So get things like um, physical clouds, right, which have volume. I can show you guys if the project runs. It should run after it compiles. And for events, you get things like screen shakes, controller feedback, full screen effects, glares, and such. Okay. And for sound and music, you have not just sound effects, which usually you want tied to cues. Cues are basically specific points tied to the gameplay or to animations or to an event on the environment, which triggers the playback of those sound effects. The background music, that one's pretty self-explanatory. And there's also the thing with ambience fitting, which is part of that is it requires code where I think a very easy to remember example is in Super Mario World for the SNES. I believe most of us have played that. When you just have the music playing, the regular music playing for that stage or for that level, and then you hop onto Yoshi, and then you start hearing the drum playing in sync behind it, like doop, 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 right? So there's this second or third or 11th, whatever, audio channel, which plays back in sync with that specific situation. And you can change the entire background music in horror-based, horror-themed games where you can get a more of a soothing music, and then all of a sudden the music becomes dramatic because you just entered um, a darker or eerier place, and then it kind of alerts the player that he or she might be attacked anytime, right? So this kind of thing, but which ambience fitting will give you for to enhance the immersion in your game. I think that's the number one thing. Yeah, it's almost done there. Should work. Let's keep moving. And then you get to the polish stage, and that one, yeah, it is continuous as well, like pretty much every other stage, but that's closer to when the game is pretty much done. And for done, that's a pretty strong word, but it's more like you get the alpha stages where not all features of the game are there yet. So just you have something playable, and that's called an alpha. So you try to get the alpha stage as fast as you can, so you can start iterating or repeating, repeating releases and getting the game better. Pretty much, it's critical to get to the iteration stage as fast as you can. So when you get to that, then you start polishing. Polishing starts from the moment you get a playable alpha. And the alpha is not, it's usually not publicly released. At max, you're going to release it to a small cohort of people, maybe some hired contractors if it's a big company. I remember Electronic Arts, they had two groups for QA, which is quality assurance. They had the QA team inside their third floor, remember, it doesn't fail me, which was a separate section. And it was kind of interesting because those were like 50 guys, um, and they had no specific requirements. They basically had to play the game and fill in reports. They, no specialty. Actually, they should be as unbiased players as possible, and they would just report bugs and check for the testing plan, which was delineated by the QA lead and of course in sync with the lead designer and the entire development team. But the development team had no contact with the QA team. That was intentional because they didn't want to contaminate the tasks, right? So that was pretty interesting. They had separate times of lunch, and yeah, even the card, the access card they had wouldn't work for them to open the door of the QA section. So of course I was an external contractor, so I had access to that. They basically sent me to a tour so I could talk to those guys, and I was developing patches for them. So I had to kind of understand how that worked, and that was pretty fun to look behind the curtain, right? But they also had another team to assure the quality of the products, which was called CQC. I can't remember the acronym, what exactly it stand for, but I knew it was quality control, and that was um, a totally different type of tester. Those were really qualified people, like um, game developers, programmers, etc., who could look at the game from a more technical standpoint. And that they had people across the globe doing that. And that was the final stage. And it did cost a lot of money, actually, to do all this QA pass. Too many people involved, obviously. But if it's just yourself, you and your family and friends, or a hired team, or even departments like Electronic Arts have, the important part is that you have to play test your game a lot, and making sure that as few bugs as possible reach the delivery date, so they keep fixing the bugs. Um, Try to play the game in strange ways. It's very common as a developer that just play what we call a happy path. And oh yeah, that's what as a designer I expect the player to do this, do that, and then first player that takes your game just goes the opposite route that you were expecting, and then falls into a hole that you weren't seeing, and then crashes the game. And like, why? You know, that's pretty common, and it's just part of the game. You got to be actually expecting people to try to break the game, or to get some advantage, most commonly unwarranted advantage from the game. And do not blame the players, blame yourself. You didn't test it enough, your team didn't test enough, you couldn't pick the bug. A curious part of that is that some of the most interesting features in quotes that I've seen along my trajectory of almost 20 years working in games were actually a result of short sights. Basically, something unexpected was found out by players, and that totally changed how the game was supposed to be played. But that actually improved the gameplay. It made the game more interesting. One of those clear examples is Rocket Jump. You guys probably heard about it. First person shooter games, you get a rocket or missile style weapon, you look down and you fire and you jump at the same time. And that propels you to reach parts of the map which would otherwise be unreachable. And when this first happened was in Quake 1. And John Romero said it multiple times. He was one of the lead team match maps, or what was it called? Deathmatch maps developers. And he said he had no idea people would ever do such a thing. He thought the first time he saw it, he was like, that's ridiculous. Who would literally shoot himself on the foot? That makes no sense. But with the armor, and the players just connected the dots, with the armor that you could collect on the maps, you could survive actually a good amount of shots, right? Right at your feet. And by jumping and with the physics, they would just be propelled upwards. So they broke the game in a sense, but it was positive to the gameplay. So it was never fixed, it was never patched out. So some of this, what we call emergent gameplay, should not be fixed, but exploits obviously should, because they detract the experience to other players, right? Yeah, so improve the game feel continuously. Maybe the game's boring because it's too slow. Maybe the game's too hard, and that's part of tweaking difficulty that you guys will have to handle. But never stop until the release date. In some moment you have to stop, but after that you have the patches, and then you keep improving performance, improving game feel, and adjusting the difficulty to and tuning the difficulty so it's right. And I leave a hint to you guys. The hardest difficulty level to set up, and I mentioned that on a class that we had yesterday in the game developer program, the hardest difficulty level to create or to set up as a developer is not the hard. The hard difficulty level is easy to set up. But the easy difficulty level, that's hard to set up. I know it sounds strange, but the fact is, since you're playing your game so actively all the time, when you think you're creating an easy experience, it's still hard for a really new player. A newbie will be totally lost in your game, just looking at the UI like, duh, literally not knowing what to do and just clicking really slowly and trying to figure out things. If it's a controller, be like, sidestepping, and you're like, what are you doing? If you check the player playing, but the player's just trying to figure out how to do things. And regardless of how well you do your job, whatever you think it's easy, it's still gonna be hard. So yeah, try to watch someone really a real newbie playing the game. That's gonna give you multiple hints for what you should make really easy, so that it feels easy and not alienate the not so proficient players or younger public, depending on the target public for your game, right? Um, yeah, so we reached the end of our short presentation. I'm gonna open up the two questions. And before we talk about those points, let me just see if the game finally opened up. Oh, it did. Good. Because I want to show you guys some of what I mentioned there. So you got here some particles. Let me just enable the game view. So you can see the specific particle of this emitter being emitted here, and that's a mana collectible item. You have this heart collection. Actually, it's a potion item. I just added it because it looked cool, and that's a free pack that you can just download from Fab, which is it's part of the Epic's ecosystem. It's their asset store pretty much. And yeah, you see how pretty it looks. And but yeah, you have other types of particles. So for instance, when I'm playing this game here, yeah, so I'm controlling this character, and you have the AI system going, um, and yeah, holding the weapon and this kind of vampire servant, and all of that, the AI implementation is something that you learn how to do effectively, and to make it scarily look at the player. During GDP, we developed this kind of content, but and the UI setup like you guys are seeing at the bottom left and bottom right, all of that. But yeah, more importantly, we yeah, the servant is far away now. Let me move away. Let me cast spell on that dude. So you can see here a shader that I use to show the targeting area, right? And that's created procedurally. So that's how you can, oops, here's the enemy. It tried to attack me. Nope, bad luck for you now. So now he's on target, as you can see from the particle being emitted at the bottom. And I'm gonna cast a spell onto it. And you can see the particles, popping up on top of the guy. So here's the animation for the casting. And yeah, now yeah, I didn't work on it because I wasn't targeting. Okay, so now it should work. Okay, there you go. So yeah, it's now slowed down with the slug spell. So you have all those effects from casting, from the particles, from, for instance, the fire here. You got a little bit closer. Some of those fire emitters. That's a Niagara system recreated in the course, just like pretty much everything they're seeing here, right? So here, all the particles, you can see, let me show those real quick. Um, Let me get the dark soul, that's the slug spell. Yeah, the last flame. This one is a particle system that we use for the torch, and this one is actually sprite based. If I change to wireframes, you can see that it's all a bunch of quads, which is basically a rectangle or a square shape, two triangles. It's like the simplest flat plane you can get on a GPU, right? But the way that they are created, the change in size, etc., this can be processed on your CPU, basically in your computer, right? Your central processing unit, or on the GPU, which makes like the smoke, which makes it much faster, but you have less properties which you can play with because GPU is a bit more restrictive in what you can send to it and still get its speed advantage, right? So this is the kind of effect that you get using just images, and you can also do using fluids. You can, let me show you guys, there's the Wraith. You can have the BP Wraith somewhere here. No, we don't. I think I deleted it. Let me show that to you guys. Open Fluid Paint Editor, import. So you, for instance, you have this creature here, which is animated. It's got its own animation system, all of that. And you can be, you get a separate position here. Probably here, it's good enough. And you can attach the particles to it. Let's try to find the um, see, yeah, the rye smoke. There you go. That's a bit hard to understand by itself because the character is not set up there. But that's basically a system where you can emit fluids, so it leaves a smoke trail and it takes the shape of the mesh, and you can see all the fumes. And differently from sprites, this one doesn't use quads, right? So if I go to wireframe, you will not see anything because it doesn't use polygons. So this is what you can use for very realistic things like water splashes, um, you know, any types of fluids really, lava, liquids, smoke, and make it fully realistic in 3D space. It's obviously a performance hog, so you have to optimize it as much as possible, but the visual result is always quite impressive. Okay, so that's another way for you to create, and that's something that Unreal has by default, which you'd have to use a plugin to bring in VDBs and other file formats created externally into Unity, for instance, right? So yeah, that wraps up what I wanted to show in terms of the engine. But yeah, at the end of the day, you have to remember, I want you guys to take that as a final takeaway. The game development is complex. It is not easy. It is time consuming. Yeah, very time consuming. And it's multidisciplinary. So if you want to do them by yourself, get ready to learn many different things. So yeah, game development is not fun. That's a myth. It's hard work. It's gonna kill your nights. But if you really love it and you learn to love it, it's hard to, love it from start. But if you learn to love it, it's the most rewarding creative process for interactive artifacts that you ever have the chance to do in your life. There's no comparison to the feeling you have when you finally get the artifact, the game on the hands of a player, of a friend, of someone you don't even know, and then the fair that's trying your game for the first time, and you see the person having fun. It's the closest thing to magic you can imagine because you basically built a fun generation device out of thin air using your brain, your skills, and the tools and learning that you have available. And you have so much available these days. Anyone can start learning with the tools for free and all the tutorials, all the videos and guidance, the expert guidance that you can take from courses like GDP on Vertex School. And yeah, guys, if you want to go for that ride, yeah, please join us. It is a little bit of madness, but yeah, the payback, the like I said, the joy, the happiness of getting games completed, being part of a team whenever it's, you get the chance. It's just, there's no comparison. I've worked with advertisement, I've worked with web publishing, creating sites, sheer programming, apps development, iOS development, whatever you can think of. I've worked with many, many things, and nothing compares to the fulfilling you get, the rewarding, the reward that you get from game development. Okay, so let me check for the questions now. Um, all right. Brum, 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 brum. Linda mentioned that first learned to rocket jump in Halo. That's great. Um, also said that the Unreal takes so long to build, results are incredible. Um, there are two features in Unreal that maybe you didn't get to try. Of course, if you do things in blueprints, it's faster. But if you're going for C++, there's the live compilation button inside Unreal. I think I shut it down. No, I have it here. So this guy here at the bottom is amazing. Basically, it recompiles and reloads all the C++ code, or at least the modified C++ code from the last time that I built it, and it just brings in the diff and it makes compilation like take like 4 or 5 seconds, sometimes a little bit more, but not a long time. Compiling everything from scratch, obviously, it's gonna take a couple of minutes, like you saw. But yeah, that's a really good thing to try and work with. Um, Linda also mentioned about how critical it is for QA to work side by side with developers. Yeah, yeah. I think EA's strategy was right. That not having them interact with the developers themselves. Basically, the lead QA would talk to the lead producer or the producers, but never to the artists themselves, never to the programmers themselves. And it wasn't about protecting the devs from critics. That wasn't the point. The point was not to contaminate the QA testers with information that the entire team already knew, but the general public didn't. So the QA testers were basically a sample of what would be the general public playing the game. So that's why they had all this kind of secrecy. It wasn't secrecy. Well, it was separate part of development, very separated, different floor, different access, different times for when they would check in and check out. So it wouldn't even cross in the corridors. It was like that. I found it really interesting. Like it felt a little bit like, what the heck? But when I realized why they were doing what they were doing, it made lots of sense. Okay, so let me keep moving. Yeah, Linda mentioned about Halo, and then Jess said that finding non-gamers to play test your easy level, or really, players who don't love your style. It's pretty hard to get someone who's a non-gamer totally to play games. Like, I don't like games. Yeah, but try my game. I don't think that's a good measurement, honestly. But if you get someone like, I hate fighting games, but I love playing MOBAs, that's a good candidate. Like, yeah, I hate fighting games. Come on, try mine. I don't like fighting. Come on, try this fighting game. It's already a player, right? So it won't be like totally averse to picking a controller or using a mouse and keyboard to play, but it'll bring you a different point of view. And sometimes, many times actually, a very shallow or I would say weak praise from someone who doesn't like the genre is worth more than 10, super excited praises from people who already love that genre. Because players who love that genre, they're usually just excited because it's a new toy in the genre they want to play. Like I love FPS games. You put an FPS game in front of mine, I'm like, okay, let me play it. I'm excited just because it's an FPS game. You know what I mean? That's the kind of thought process that I use to pick testers and value the feedback that I get from testers. Um, for audio, what middleware is best to know? I use Audacity myself, but if you're a professional sound designer, you'd be using other tools. I'm not, the best source of information for that. For my general needs, Audacity, it's the free software. It does pretty much all that I need. So I never like sometimes you have to learn a lot in terms of the game engine and how to play with the sound sources to for them to work exactly how you want them. Things like suppose you have the servant, that's a vampire servant, by the way. That's it's not a zombie. I know it looks like a zombie, but it's a different thing. It rushes towards you, it has other abilities. But anyways, suppose you want some echo going from the sound of the screaming, screeching sound from the vampire servant as it goes into tone. That's not something that the raw audio will have. It's something that the game engine will provide, right? So that's when you really have to master what the game engine gives you in terms of um, the, the 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 echoing properties, or if you want to randomize the scream sound by changing the pitch, randomizing the pitch at each shot, for instance, from the gun that you pick. That's a common approach to make the sound not super repetitive. Like instead of bang, 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 bang all the time, you got like bang, 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 that, bang, some slight variations that will make the game feel more realistic. So learning how to handle the audio tools inside the engine, it's way more important to a pure, let's call it that, pure game developer than learning high-end sound tools. But that's probably my point of view because I'm not that big into audio. But Audacity, like I mentioned, it's very. I know it's used by some professionals at least for parts of their work, so I'm sure it's a competent program. For anyone starting out, are there any places or communities for when you're stuck or on something during game dev? Definitely, definitely. For Unreal, the Epic Forum, you got things like, let me get it here. Unity Answers. If you go for Unity, you find lots here, and it's now moved into Unity Discussions. You go to, and I click Unreal Forums and find it easily online, where you get information, specific information. And of course, whenever you're stuck, if you even go to Google, you get some AI insight, which is good to check, but don't trust that without, totally. If you're just experimenting for something, fine. But always check for the reference. Always check for the links, because that's the only way you can assure that it's giving you right feedback. The most common filter suggestion that I can give you guys is that if the AI won't find the answer, especially on simpler AI systems like what Google gives you for free, it will make up one, right? That's so don't get scared when you see whenever, like, can I do this in the engine? It's 9 out of 10 times it's gonna tell you that it can do it even if it cannot. So yeah, always double check. But if it can do what you're asking, it most commonly will give you the right answer. But again, always check the references that they're listed at the right side of the search page, right? If you use Google or if you use some other search engine, make sure that you're checking the references all the time. So forums are the number one source. And check for Discord channel. They're very active. And if you need something really quickly and you can't be helped by the other options that I mentioned, yeah, the score is where you find the fastest response rate. You also have some great Reddit groups which reply really quickly. But yeah, I would go in terms of speed, I would check for the score, super fast. Um, Reddit groups, especially the bigger ones, search for the big ones, pretty fast, like sometimes minutes. Um, 10 minutes max. And in the forums for something you need something, a deeper response from the experts are usually around the forums, right? If you want to make a diegetic UI that sits inside of a cockpit, it's kind of be glass and gives visual clues from visual direction, margin, and borders that can be meshed. What I need to do that via shader and how? So yeah, a screen shader would be a good idea, right? It really depends on the game you want. I remember for Taikadon, we had those UI elements. I totally know what I mean, where you try to show the direction of the player, of the enemy NPC ships and other elements on the space, and especially if it's a space game, it's pretty hard to convey positioning using 2D graphics, even UI overlaid elements. So you can use shaders on full screen effects in any of those engines. And shaders, you can build even vector-like graphics. So just to quickly show you one of those, well, I think I've shown the decal, but I'll show again. Um, yeah, that's the target. Oh, that's a material instance. My bad. Target, target sector. Yeah, that one is hard to see from here. Yeah, there you go. Now you can see it here. So this is a sector where you can define parameters, and you have this pretty decently complex setup where you can adjust things like the max radius, min alpha, max alpha, so you get this decay. This could be applied on top of the entire screen to get the effect they want. So for instance, here, let me try to play with the angle, right? So now I'm making the angle wider. I'm making it narrower, and I can make it more, more or less transparent here at the edge, or more solid or less transparent at the inner edge. So using those techniques, you could build your arcs, right, for your HUD, because this is 360. It's using arc tangent too, which allows it to be, if I set the angle here to, I don't know, 260, you see that it takes the full circle. Anything above 180 degrees, it's going to take all that. So you could use that applied on top of your viewport, and then you just use the HUD class on, if you're on Unreal, you do that on your world settings here. You just add the game mode override, um, or you go to the project settings and select the maps and modes, and you will build your own um, default template, which takes its own HUD, right? So because that's the trick. When you have your own HUD, like I have one here, I created, you can no, I don't want to change anything. Uh, This is the HUD inherited class. You can literally override it with your own widgets. And your widget can use a texture like that, right? So the texture, the material, actually, not the texture. So the material will be applied, and then you can have multiple visual elements created. If it's 3D, obviously you wouldn't go shader. You'd have to do a separate pass using probably a texture renderable camera to output from one specific area, hidden area of your level where you generate this mesh, right, which you're overlaying. But if it's 2D based, I think the best bet is going for a separate HUD with your own widget. Certain YouTube channels to learn audio integration. I wouldn't know right now to tell you that. There are certainly multiple YouTube channels focused on real development, Unity development, and audio for games in a generic fashion. But for integration, I would look into the game engine focused channels, right? Um, it is not so common to have tutorials about audio, but you do have them. Just do a quick search and you're going to find them on YouTube. Question more on the overall development cycle. How agile are, or agile, how people say it in Europe, are modern games developed? Is everything planned theoretically in the GDD and then it's executed based on that? Or is it more like you start with the vertical slice and then check how the game feel is, then adapt what's missing for a full game? How's it in the big studio? That's a great question. It really depends on the scope of the game. So even on a big studio, like for instance, Big Fish Games, we it was a client for us in First Foundry, and they work with small games, like, but sometimes the game is small in terms of the mechanics, but it's big in terms of content. And then you have all these layers of game design documents for the content, but the actual mechanical design for the vertical slice, as you said, or a prototype or minimum viable product, like usually it's commonly called inside studios. It's a small subset, it's very small, right? So you have those layers, and it's very common nowadays. I was actually showing that yesterday, so I didn't close it. So for instance, this is a design I did for a pretty simplistic game. It's not a complicated one. It's like a Plants and Zombies using bats, right? That post-apocalyptic, um, radioactive, mutated bats. That's the story. And then you define the units, how they behave, and the heroes and whatnot, and you keep basically branching things like structures, what you have in terms of structures, what you have in terms of missions, what you have for the actual levels, and but most importantly, you want to work on the progression because each mission needs to have like a story. It has to teach something. It needs to be interesting and to add something to the board, to the table, right? So yeah, basically defining all of that, what you have in terms of UI, what's the screen flow, the panels. And this is all design based. I know today wasn't a design oriented lecture, but yeah, that's roughly how we work things in layers and pages. It's very hard nowadays for you to find a single design document as it used to be like 20 years ago, where you have this big design Bible with 20, 30 pages. That's not very efficient. Nowadays, you focus on sub pages for each specific element of design, which we call design specs. It's a term that I learned during my tenure in electronic arts, and it is very effective because it's just a small slice, and then you can have sub teams of designers, or you can have a rotation of designers working on multiple specs. And those specs, they are leaves on a big branch of the design approach, just like I'm showing you guys here. So you have, those branches, and for each branch, you can have multiple sub pages where you detail a mission, you detail a map, you detail the market, how does it work, how does it integrate with resources and games, and the progression overall. Guano Wars, it's literally that. Okay, guys. Well, we hit our deadline for time. I have to thank you guys for the questions. Very, very cool questions, and for your patience, for your audience. And make sure to check our program and its syllabus and what we can add to you guys' understanding of game development. And remember, you get technology, information is everywhere, but that's just information. You usually it's much faster for you to develop yourself in a career when you get you know um, the experience from someone and being able to, like we do, live classes, not just pre-recorded classes, and on a regular basis, just answering questions. We have one day of the week focused on that. So yeah, check on our programs, and if you're interested, check out with our team how you could join us. Right? Thank you very much, and I hope to catch you guys later. Cheers. Bye bye.